Today we cover section 13.1 on measures of central tendency. For any set of n numbers, x of 1, x of 2, x of 3, all the way out to x of n, there are three common measures of central tendency. The first is called the mode. The mode is simply the most frequent number in the set of numbers. For example, if I gave you the list of numbers 3, 3, 8, 3, 1, 5, 8, 8, 8, the mode would be 8 simply because 8 appears 4 times and no other number in that list appears that many times. However, if two numbers appear equally frequently, we call both of them modes, and for a case like this, we say that the set of numbers is bimodal. For example, if I ask you to find the mode of this set of numbers, 7, 7, 2, 7, 1, 5, 2, 2, you'll notice that there are 3 2's, but there are also 3 7's. So we'll call them both modes, and that's an example of a bimodal set of numbers. If 3 or more numbers appear equally frequently, we say the set of numbers is multimodal. For example, if I ask you to find the mode of the set of numbers 1, 2, 2, 5, 4, 3, 5, 3, you'll notice that 2 appears twice, 3 appears twice, and 5 appears twice. So there are 3 modes, 2, 3, and 5. The mode is not affected by outliers. That means that a single value that's way larger than most of the others or way smaller does not really affect the mode at all. In fact, the mode can even be used for non-numerical values. The second common measure of central tendency is called the median. The median is simply the middle number in value. If I ask you to find the median of the set of numbers 3, 3, 8, 3, 1, 5, 8, 8, 8, the simplest thing to do is put the numbers in order because you can't find the middle number in value easily unless the numbers are ordered. So if I list them from small to large, I get 1, 3, 3, 3, 5, 8, 8, 8, 8, and from that you can see that 5 is the middle number with 4 numbers to the left of it and 4 numbers to the right of it. So the median is 5. But there can be a case where there is no single number in the middle. What do you do then? If I gave you the list of numbers 3, 3, 8, 3, 1, 5, 8, 8, 8, 9, now when you put the numbers in order, you get 1, 3, 3, 3, 5, 8, 8, 8, 8, 9. And there's no single number in the middle. 5 and 8 are the two numbers closest to the middle. And when that happens, you simply average the two middle numbers. You take 5 and 8, add them up, divide by 2, and you'll get 6.5 in this particular case. You only do that when there's no single value in the middle. So in this case, the median is 6.5. Note that the median is also not affected by outliers. A really big value or a really small value doesn't affect the median at all. For example, the median for the list of numbers 1, 2, 3, 4, 5 is exactly the same as the median for the list of numbers 1, 2, 3, 4, 50. That big outlier, that 50, does not change the median at all. The third common measure of central tendency is called the mean. The mean is the ordinary arithmetic average of a set of numbers that you've been using for years. But I do want to talk about the notation. We call that X bar. X with a horizontal bar above it is the standard symbol for the mean. And you'd read that X bar. X bar is simply the sum of the values divided by how many there are. That's the ordinary average that you've known how to do for years. There is another notation, though, that you'll see in mathematics. It's the capital Greek letter sigma. And that sigma x sub I divided by n is just another way to write the mean. And the sigma itself means sum. So it's all that's telling you to do is sum up all the x's and divide by n. So when you see that sigma, think sum. Technically in statistics, X bar is the sample mean. If you draw a random sample from a population, mu represents the mean of the whole population from which you drew the sample, while X bar denotes the mean of the sample that you drew from the population. Because we're not focusing much on inferential statistics in this course, the difference between these two things isn't terribly important to us here, but technically X bar is the sample mean, mu is the population mean. But like I said, for what we do in this course, it doesn't much matter. How about this example? Find the mean of the list of numbers 338315888. Round the answer to 2 decimal places. All you do is add up the numbers and divide by how many there are. In this case, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. When you add all those numbers up, you get 47. So you divide 47 by 9 and round it to 2 decimal places, you get 5.22. How about this? To get a B in math, Alexandria Pappas must average an 80 on 5 tests. Her scores on the first 4 tests were 84, 77, 81, 76. What is the lowest score she can get on the last test and still get a B? Very straightforward, but how do you do it? I know that when I average grades, I just add them all up and divide by how many there are. And if I want to get a B, or if she wants to get a B, that average has to come out to be 80. So just take the scores of her test, 84, 77, 81, 76, plus this last score, which is unknown. You can call it X, or you can just write last score like I did. The sum of those 5 divided by 5 has to be 80 if she wants to get a B. So now if you add up those 4 numbers in the numerator, you get 318. So 318 plus the last score divided by 5 must be 80. If you multiply both sides of that equation by 5, the 5 in the denominator on the left cancels out, and you get 318 plus the last score is equal to 400. And if you subtract 318 from both sides, you'll find out that the last score must be 82. So Alexandria needs to get at least an 82 on that last test in order for her to get a B in the course. This might be a good time to mention that this Casio FX260 solar calculator that we use has a stats mode that you can use to calculate means for you so that you don't have to do the work the long way. I'm going to show you how to do this, and this is something you need to learn because it's extremely useful. The first thing you do is to press the on key. Not only does that wake the calculator up, but it also clears out any old data. And that's important because if you are doing a calculation and you don't realize there's already data in there, it can mess you up. So press on, that wakes the calculator up and clears out any old data. To put the calculator in stats mode, you press the mode key and the dot or the period key. That puts the calculator in stats mode. Mode dot. When you put the calculator in stats mode, in the upper right hand corner, you'll see the letters SD. Upper right corner of the display. If you don't see that, the calculator did not go properly into stats mode. So after you press mode period, look for that SD in the upper right hand corner. Assuming you see that, now you key in the first number. Whatever the first number in the list, you key it in. Then you press M+. M+ is like the enter key for the data that goes into stats mode. And then you just key in each number until you get them all in, one after the other. You have to press M+ after each one. Be careful though, some people forget to press M+ after the last number. If you don't press M+ after a number, it is not entered into the stats mode. After you get all the data in, press Shift 7, and you'll notice on your calculator that you don't have to memorize that it's Shift 7, because if you look above the 7, you can see that X bar symbol. It's right above the 7. And when you do that, the calculator display will show you what the mean is. That's all there is to it. There are a couple of other useful tips I'll mention. If you press Shift 6, it'll show you how many numbers you've entered, and that can be useful because if you're typing in a list of say 10 numbers and you accidentally miss one, or if you accidentally enter one twice, one way to catch that is by pressing Shift 6. If it doesn't come up with the right number of numbers, you know there's a mistake. Also, once a number is entered, if you press M+, it enters the number again without you having to actually type the number in. And also, there's a summary sheet. If you bring up the PowerPoint that this video is based on, there's a hyperlink here that takes you to a summary sheet that tells you all these things, and it might be a nice thing for you to bring up on your computer and print out. In any case, let's get back to actually calculating means using the calculator, the Casio FX260. Suppose I want to find X bar for the data set 18, 15, 11, 31, 32. What do? Step 1, press on. That wakes the calculator up and it clears out any old data that might be in there. Then you press mode, period. That puts the calculator in stats mode. Always look in the upper right hand corner and make sure that SD popped in there. If it didn't, you're not in stats mode. Once in stats mode, you key in the first number and press M+. So in this case, 18. Then you press 15 and hit M+, and then you press 11 and hit M+, then 31 M+, then 32 M+. After you entered all the data, and again, don't forget to press that last M+ after the 32, but once all the data is in, press Shift 7. And in the calculator display, you will find the answer. Just throw these useful tips up here again, same ones I mentioned earlier. But let's see what you get. The keystrokes for that problem would be on, it clears the old data, mode, period, puts it in stats mode, 18 M+, 15 M+, 11 M+, 31 M+, 32 M+, that enters the data, and then Shift 7 gives you the mean, which turns out to be 21.4. I mentioned earlier that the mode and the median are not affected by outliers. The mean, however, is. It can be strongly influenced by outliers. And if you don't believe me, try it yourself. Take the mean of 1377 and then take the mean of 13750, and you'll see how much difference that one number 50 makes to the mean. Doesn't change the mode, doesn't change the median, but the mean is highly sensitive to outliers. Sometimes you'll be asked to calculate a mean, median, or mode from data that's presented in a frequency table. So let's look at that case. Suppose I give you a table with a bunch of scores. The scores are listed in the left-hand column, and then there's a frequency column which tells you how many times that number appears. So 12 appears once, 15 appears once, 17 appears 3 times, 20 appears 3 times, 21 appears 1 time, 26 appears 4 times, and 32 appears 2 times. Because a frequency table already has counts, it's easy, super easy to find the mode from a frequency table. You just find the score with the largest frequency. Here, there's only one value that appears 4 times. Nothing else appears more than 3 times, so the mode is 26. So a frequency table is perfect for finding modes. The median, you have to look at the numbers listed in order. So first of all, as long as the table has the values in order, like 12, 15, 17, 20, 21, 26, 32, as long as those scores are in order, it's pretty easy. Now, if you look at the sum of the frequencies, 1 plus 1 plus 3 plus 3 plus 1 plus 4 plus 2, you'll find out that's 15. So there are 15 scores. If there are 15 scores, think about it, the 8th score must be the middle score. 7 on the left, 7 on the right. The 8th score is going to be the median. So what's the best way to find the median? I would just start, assuming that the table gives the numbers from smallest to largest, like this one does, I would just start at the top and count. 12, that's 1. There's only one of them. If you go to 15, there's only one. So 12, then 15, that's 2 things. Then you move down to 17. There are 3 of those. So the 3rd number in the list is 17. The 4th number in the list is 17. and the fifth number in the list is 17. Then you keep going. You move down to the 20s. There's 3 of those. You've already counted 5 numbers, so the first 20 is the 6th one, the second 20 is the 7th one, and the third 20 is the 8th one. Well, remember, the median was the 8th one, so the median is 20. You could keep going and list them all, but you only want the median, so once you hit the median, you can stop. So the median is 20. See how that works in the table? It does assume, and you got to be careful, that the numbers actually are in order. If they're not, you've got to put them in order. So here the median is 20. You could have actually, if the numbers aren't too large, you really could have just listed them all out. So if you wanted to write 12, 15, 17, 17, 17, 20, 20, 20, 21, 26, 26, 26, 26, 32, 32, you could, and you could have found the median that way. But you really don't want to go to that much trouble. It's much easier just to go down using the table and count till you get to the middle value. What about the mean? Well, it's easy enough to do it with your calculator. The first thing you want to do is wake the calculator up and clear out the old data if there is any. And you do that by pressing on. Then you do mode period. That puts it in stats mode. Always look in the upper right and make sure SD comes up. And then you enter the data. There's 112, so you do 12M plus. There's 115, so you do 15M plus. But there are 3 17s, so you type 17 and hit M plus 3 times. Then you go to 20. There are 3 of those, so you type in 20 and then hit M plus 3 times again. Then you go down to 21. There's only 1 of those, so you press M plus once. Then you go to 26. There are 4 of those, so after you type in 26, you hit M plus 4 times. Then you go to 32. There are 2 of those, so after you type in 32, you hit M plus twice. And once you get all the data in, you do Shift 7. And once you do Shift 7, the calculator display will give you the answer. And in this case, it's 21.8. So the mean is 21.8. Now let's talk about something called a weighted average. When some values are more important than others, we use a weighted average. The table below shows Dylan's fall semester course grades. Use the weighted mean to find Dylan's GPA for the fall semester. An A is worth 4 points, a B is worth 3 points, a C is worth 2 points, a D is worth 1 point, and F is worth 0 points. The table shows you the courses in the first column, the course grades in the second column, and the course units, which are basically just credit hours for each course, in the third column. The first thing you'll want to do is get rid of those letter grades and put in their numerical equivalents. So a B is worth 3 points, an A is worth 4 points, a D is worth 1 point, and a C is worth 2 points. Once you've done that, you look at that table. The course grades, now that they've been changed to numerical values, are what we're trying to use to calculate the GPA. The course unit column are the weights. It tells us, for instance, that a 4-hour English course is worth more and weighs more than a 3-hour history course, and so on down that list. So the course units represent the number of credit hours for that course, and those represent the weights. The second step is to add up all of the weights, that being the course units. 4 plus 3 plus 3 plus 4 is 14. So Dylan is taking 14 credit hours this fall semester. Next, you want to multiply each value, the course grade, by its weight. So you get 3 times 4 in the first row, that's 12. 4 times 3 in the second row, that's 12. 1 times 3 is 3 in the third row. 2 times 4 is 8 on the fourth row. And then you want to add those products up. 12 plus 12 plus 3 plus 8 is 35. And finally, you take the sum of the products in that product column, the last column, and divide by the sum of the course units. In other words, the sum of the weights. So the GPA is 35 over 14. If you divide that out, you get 2.5. So Dylan had a 2.5 GPA in the fall semester. I will say that if you want to work this problem as if it were an expectation problem from the previous section, you can do that. All you have to do is change the weights to percentages. So if you take those course units, which represent the rates, and make them into fractional percentages, in other words, English is worth 4/14 of the grade, history is worth 3/14 of the grade, chemistry is worth 3/14 of the grade, and algebra is worth 4/14 of the grade. In other words, divide each course unit value by the total of the course units being taken. That basically changes that course unit column into a percentage column. At that point, it's just like an expectation problem that you worked back in the previous section. So in the previous section, you learned that you could multiply across, multiply across, multiply across, multiply across, and then add. And when you add all those fractions, you end up with 35/14, which is the same thing we got before. You get exactly the same answer. So I'm not advocating that you do it that way. I'm just saying that if it makes sense to you to think of these weighted averages as just an expectation problem, you can do it that way. All you have to do is first change the weight column to percentages. It's up to you which way you want to do it. Now let's take the Dylan example and push it forward into the spring semester. Suppose Dylan's spring GPA was 3.4 on 16 course units. In other words, he actually did better in the spring than the fall. He had a 2.5 in the fall. Well, he got a 3.4, much better in the spring. And he was taking more credit hours too. He was only taking 14 credit hours in the fall. Now he's taking 16 credit hours. So I want to figure out Dylan's cumulative GPA for that whole academic year, the 2 semesters together. If he had taken the same number of credit hours both semesters, all you would have to do is average the 2 numbers. But because he took more hours in the spring and the fall, you must treat this as a weighted average. So what we're going to do is treat the GPAs as the values, the 2.5 and the 3.4, and the weights will be the credit hours, 14 and 16, and make a table. So one column are the values. Those are the actual GPAs, 2.5 and 3.4. And the credit hours are 14 and 16. So Dylan had a 2.5 GPA taking 14 credit hours in the fall, and he had a 3.4 GPA taking 16 hours in the spring. Then you want to take the products, 2.5 times 14 and 3.4 times 16, and that gives you 35.0 and 54.4. Then you want to sum up the products. That's 35 plus 54.4, that's 89.4. Then you want to sum the weights. In other words, how many credit hours altogether was he taking? That's 30, 14 plus 6. And finally, the GPA is going to be the sum of the products, which is 89.4, divided by the sum of the weights, which is 30. So Dylan's overall academic year GPA for the fall and spring together was a 2.98. How about this one? Mark averaged 60 miles per hour during the 30-mile trip to college. Because of heavy traffic, he was able to average only 20 miles per hour during the return trip back home. What was Mark's average speed for the entire round trip? The thing about this problem, it's a weighted average problem, and it's pretty clear we're looking for a mile per hour answer, so the 60 and the 20 mile per hours are the values in the problem. But what are the weights? You have to think about that a minute. He gets to college pretty quickly going 60 miles per hour, so he's not in the car as long going, but when he returns back home, because of the traffic, he slows down, so he spends more time in the car. So if you think about this, the more time you spend at a certain speed, the more that speed should count. So the slower speed took more time, so that slower speed of 20 miles per hour should count more than the 60 mile per hour speed because Mark was not in the car as long at the faster speed. Having said all that, what it amounts to is that the values are the MPHs, the miles per hour, but the weights are the times. The problem is the times aren't actually given. That's not that big of a problem because we know from algebra that we can figure the times because we know the distance and the rate by using the formula distance equals rate times time. So just look at it. On the trip to college, if you use distance equals rate times time, Mark went 30 miles at 60 miles per hour, and we're looking for the time. If you divide both sides by 60, you find out that that trip took Mark a half an hour. Returning, it's still 30 miles, but he was only able to go 20 miles per hour, so you get 30 equals 20t, and if you divide both sides by 20, you'll find out that Mark actually was in the car for an hour and a half on the return trip. So now we have the weights. We had the values to start with, the 60 and the 20, but now we have the weights, half an hour and 1.5 hours. So we build our table. The values are the miles per hour, that's 60 and 20. The times are the weights, that's half an hour and 1.5 hours. Once you set the table up now, you take the product of 60 and a half, which is 30, and 20 times 1.5, which happens to also be 30. Then you add the products, you get 60, 30 plus 30. Then you add the weights, which is a half plus 1.5, that's 2. And the average speed then would be the sum of the products over the sum of the weights. That'd be 60 divided by 2. So Mark's average speed for the entire trip was 30 miles per hour. And notice that the 30 miles per hour is closer to being 20 miles per hour than it is 60. And that's because Mark spent a lot more time in the car at the slower speed.